Can we also talk about number 2, the oxidation and reduction reactions? Because I thought I understood like which one is oxidized and which one is reduced. And I think I might just be confused by how it was supposed to be put in.
Yeah, I got that wrong too. I was about to say.
Yeah.
Which one? Which one specifically did you guys get wrong?
I got like all of them wrong.
Yeah, like all of them.
Oh,
yeah.
Okay. Let me see if there's something wrong with the key first, just to go over this. But while I'm doing that, I'm actually looking at it right now.
I think you guys probably got confused between what the oxidizer and the reducer is as opposed to the oxidized and the reduced. Apparently it's like there's a difference.
I mean, can we still go over like 1 or 2 of the questions in it?
Yeah.
Because I feel like I'm missing something important.
Okay. So let's just go with the very first one. So we have iron and oxygen, pure iron, pure oxygen, reacting to form ferric oxide. Is it ferric? I get confused. I think ferric is 3+, ferrous is 2+, but I always get confused. In this case, I don't really know. I'm not looking at it. Let's see, what would this be? 2, that's 3. Anyway, so in general, the way I go through this is first I just try to identify the electronegativity of whatever we're looking at. In this case, it's just two reactants and one product. Generally speaking, if you're dealing with a metal and a non-metal, I can't think of an example. I'm sure there can be one, but generally speaking, as a rule of thumb, the metal is going to be the thing that is oxidized, and then the non-metal is going to be the thing that does the oxidizing. And that's just due to electronegativity. If you guys want to think about this conceptually, and this helps me, so this is for electronegativity. Basically, you analyze electronegativity of all the relevant elements or species, if that's present. Like there's nothing here in this case, but like you will see common ions like sulfate or nitrate or hypochlorite, which is something we're using in this lab. These you can consider them to be almost like elements because they're very common and they stick together and almost act like a like a macroscopic element, basically. Not microscopic, but they're common ions. Anyway, so something to help with electronegativity, basically the rules of thumb, and then we're kind of learning about this in this lab. We're trying to empirically determine this, but electronegativity increases the further right you go on the periodic table and the further up you go on the periodic table. And the reason for this is that every atom is composed of a nucleus, and the only difference between elements is the size of the nucleus and the amount of electrons that can orbit around that nucleus. So the larger the nucleus, meaning the more protons and neutrons, the more electrons can orbit, because there is typically a balancing act between number of protons and number of electrons. But to get straight to the point, the nonmetals have reached a sweet spot. Basically, so the proton and neutron are a fixed size. They don't get larger or smaller, even when the element itself gets larger. When an element is increasing in size, so if you go like down, let's say the alkali earth metals or something, and increasingly the atomic radius is increasing. That atomic radius, really the size we're talking about is the electron sphere, because the size of the proton and neutron is negligible compared to the huge overwhelming just volume that is the electron sphere. So if you guys remember from electricity and magnetism, which I don't remember the formula, but there's a formula for the electron for charge density, and that's it's related to the actual charge itself and a volume, and then it's like an inverse of radius over pi or something like this. I can't remember, but basically you can think that the further away you are from the charge, the weaker that charge is, right? Pretty straightforward. So the larger you get, as in the more electrons you add to the sphere, even though the number of protons is increasing, the effective charge of those protons is decreasing because there are more and more electrons that are further away from the nucleus and instead are actually shielded from the nucleus by other electrons. And conversely, the smallest atoms that have a the smallest atoms that have a good number of protons, but only but the smallest number of valence shells. So this is the topmost, or this is basically the 2 pi elements, and everything that's close to them are going to have the highest charge because they have the largest nucleus relative to their shell size. So for example, fluorine only has 2s, 2p6, or 2p5, but it's usually 2p6. And then so 1s to 2s2, 2p5. So it only has 3 shells over it for a pretty big nucleus. Whereas if we just go 1 row down, we're putting another 2 shells on top of that, and the volume increase per shell is much larger than the volume or the charge that you see, or the volume increase of the proton is much smaller than the volume increase for the electron shell. So I guess, I don't know if this is even helpful or not, but what I'm trying to say is, I don't know if this is helpful, but basically you can think about sizes if you're interested in electronegativity. But anyway, so to go just to go to this, so we have iron, which electronegativity is like around 2 something. And then oxygen, which is pretty close to 4. It's 3 point something, like 3.7, maybe 3.8. I can't remember exactly. I'm just going off of long-term memory that I did a long time ago. Obviously, if you see oxygen anywhere, there's a pretty good chance it's going to be an oxidizing agent. I mean, as the name indicates, oxygen is, I mean, there's a reason why it's called oxidation, because the oxygen acts as a strong oxidizing agent in almost every circumstance, because there's only one element in the universe that is more oxidizing than oxygen, and that's fluorine. And the relative abundance of fluorine is nothing compared to oxygen. And oxygen is just, not only is it relatively abundant in terms of an element, it's ubiquitous. It's found all over the world. It's found in the atmosphere, it's found in minerals, it's found in biological materials, it's found in everything. So right there, that should be a good indication that oxygen is going to be oxidizing iron. And so what that literally means is that oxygen is has an even, a mutual reciprocating bond with itself, O2. So it's neither oxidized nor reduced. It's completely balanced. Same thing with iron. Iron is bonding with itself, so it's forming like a big lattice. Like, remember when I did the lab 4, when I just had pure zinc and pure copper? It's the same thing. It's a big lattice of just itself. But when we're exposing oxygen to the iron, those electrons in the furthest end, those electrons at the very end of the metal are not held very well. This is actually a reason why some, or maybe, I don't know, some, probably a lot, but I mean, I don't know every single metal, but let's just say a lot of metals are conductive because they can't hold on to the electrons very well. And they have, when they form big lattice structures, those electrons are held pretty far away from the shield and are kind of loosely held. And then when there's another charge that's put from the outside, if there's like a potential, you can actually basically create a flow of electrons down the metal. Anyway, so oxygen reacts with the iron by stealing some of those outermost electrons. And in the process, it oxidizes it and becomes itself reduced.
Yeah, I think the part that kind of confused me is that what it was asking for. So at first I thought it was asking for the oxidizing agent and the reducing agent, as opposed to which one is actually being oxidized and which one is being reduced. That's what was the confusing part, I think.
I also got confused with the charges that you put in after. Like for oxygen, for the first one, I put that it was 2- after, and it marked me wrong. So I don't know.
Yeah, the 2 minus thing actually should be corrected because that's true. I'm not sure why the key doesn't have that, so I'll correct that for the key.
And would iron have a charge after it's oxidized or no?
It would.
Because I put 3+ and the key just says it's just iron. So I don't know.
So looking at the key itself, it's pretty inconsistent because sometimes it actually has the charges and sometimes it doesn't, which is kind of unfair for obvious reasons. I would say for my interpretation, like if this is a quiz and I just gave you guys the quiz, if you give it to me with or without charges, I would accept it. So I'll go back to this key and I'll just modify that because really the question is just asking which was oxidized, which was reduced. It wasn't asking how much it was oxidized, how much it was reduced. So in that case,
it said to include charge if applicable. That's why I assumed we would have to put the charges in. Otherwise, I would have just put the elements.
Does it say it on the lab homework instead? Oh, it does. It doesn't say that on the lab worksheet though. Okay, well, especially in that case, then yeah, I'll add that because I don't even know why they didn't include it on the key because that wasn't an initial homework problem though. It looks like that was just a modification they put to this online homework.
Yeah, I didn't put it in because that's not how it was on the lab homework. I literally just do my lab homework and then I just input everything else in there. So
yeah, I'll modify to take both of them because there's a discrepancy. So that's not fair to you guys. So it says it literally, it says it, one thing says it, one thing doesn't say it, and then even still, let's say that it said it on both things, include charge. The key itself has answers which don't include a charge. So you guys are going to get things marked wrong which aren't wrong. Once again, there's just a problem with the input grades. So or with the grading scheme with the key. So I just need to correct that. So I'll correct that. Can someone take a screenshot of that or just take it, like just put that in Discord. I'll put that on too, but maybe as an example. Or did you put that in here? No, let's write this. This is question.
I can do it. I'll put it in.
It's question 2 regarding charges, right?
I also had a question for the net ionic equations. This one might be kind of dumb, but I put after the chemical name +1 instead of 2+, or I put +2 instead of 2+, and it counted me wrong. Is that the wrong way to write it? Do I actually need to write it 2+, or can you write it either way?
You wrote it 2+ as opposed to.
I wrote it +2 as the charge instead of 2+.
It does matter, but I don't want to be too harsh on that. I would say that, yeah, so the potential ambiguity might be that if you wrote 2+, even though I understand what you're writing, it could also be seen as 2 copper, and then maybe 2 singly charged copper. So copper 1 and then 2 of them. So it's not the correct notation, but I think that's a relatively minor thing. So I think we had this problem actually before, and I can't add half points, but I can manually change the grades. So for those students who've had that, last time I had this, I actually just went through every single problem manually, and I just saw if students had done that or not. But it's really helpful if you guys tell me if that happened to you. So I'll write that down too for the grading. So I had to find out how to put that in there, because right now the grading is all or nothing, which is a little bit too harsh, I think, for this. Okay. So that's question 3, right?
That one was question 4 and on question 2. Nope, 3 is a net ionic equation also. But I somehow did it right on 3, but not on 4. So
okay. All right, so I'll just write for question. I'll write for question 3 and 4 in case there are other students with that same problem.
Okay, thank you.
think I actually may already have something like that. Yeah, I do. All right, any other problems with the homework? Respond to the student. Okay. So let's see, I just want to make sure we got everyone in the chat. So there's a question regarding nitrite. Did you guys figure that out already? That's on 1B. Let's see, what did you guys ask here? So yeah, so you guys figured out with the nitrite that it's overall neutral molecule despite there being different oxidation states between the oxygen and nitrogen. I think you guys got the iron thing figured out. Okay. So it looks like we can move on, and that's fine because the homework's due in 4 minutes. All right. So I sent you guys an email earlier today with the lab that you'll need for this week. Excitingly, this is actually our last video lab. I think that's pretty exciting because it's the last formal lab report in the way that you guys have been writing them thus far. So the simulation labs that we'll do for the last few weeks of lab will be shorter and easier. So that will be fun. The next 2 labs are, as per the schedule, let me refresh because I do not remember exactly, are calorimetry and gas laws. So I'm not exactly sure what Dr. Fuller has in mind for those. We have not talked about them yet, but they are something you'll be doing at home. I do know that for one of those, and I think it's gas laws, and she might actually change that to be the week after next. I'm not sure. I'm just speaking from memory from a meeting that I went to a few weeks ago with her. But one of those will be a little bit different from the lab we did last week, in that you guys will, it'll be similar like this. So last week you guys had to find your own cookie recipe, and then you did the lab, which is pretty cool. That's really cool. For the gas laws, from my knowledge, or at least what she has planned, you guys will actually end up proposing your own experiment, basically. So we'll give you like a concept and then maybe some ideas. Again, I don't know what she has planned, but this is what she talked about. And then you will get to basically design an experiment that you think will answer the question, and then perform it. And then instead of writing a lab report, you will basically do something like a presentation, like you'll submit like an actual presentation, like a PowerPoint, basically highlighting it's the same thing as a lab report. You'll still have the objective, you have a background, you'll have the procedure, the data and results, calculations, and then conclusion. The only difference is in presentation and that you're writing it in a kind of easy to digest format and showcasing why you chose this, why you think it worked or why you think it didn't work, and then what did you get. So when I have more information on that, I'll send it to you, but right now I don't. I just want you guys to be aware of this, if that's something we're gonna be doing. On that note, actually, I want to go back for a second. So how did the cookie lab go for you guys? Was it okay?
Mine was good, except for the part where I wrote about how the middle just kind of caved in. So
Okay.
it was an inaccurate measure, and I had to go back and remeasure the sides.
Okay. I am actually I'm really looking forward to reading these reports. Yeah, go ahead, Pablo.
Yeah, is it okay if our cookies turned out more flat than like the shape that we were actually supposed to get, which was like a dome size?
Yeah, I think it's fine.
Okay.
So like I said in Discord this morning, pretty late, was the kind of objective of this lab is a lot more how do I say it, open-ended than the other labs, which makes it just much more exciting. This lab was really designed for you guys to use what analytical techniques you've learned so far and then apply them to a novel problem. So instead of us just telling you what to do and then like taking observations and whatever, you're using whatever like statistics that you think are relevant or just data analysis again that you think is relevant to propose a relationship between the two things we're looking at, which is temperature and the temperature and the volume. I was thinking the moles of the gas, but that wasn't it, just the volume. So whatever you guys get and whatever the data get is whatever the data is. I don't know if I'm going to, I don't think when I look at this, unless the data is just like, so like the data is what it is, right? I don't know if, unless it's something really crazy, I don't think I'm gonna take off points for the data. Really, it is what it is, and I just want to see how you guys analyzed it, and if you analyzed it correctly, if you presented the data correctly, like if you have the right axes, if you did things correct according to the tools you had, then that's all I'm expecting. That's going to be exciting to see your guys' thoughts on this because there's a lot more room for interpretation, I think, than the other labs so far. So I'm saying this because I remember seeing a question on Discord about the statistical analysis for that trend. There isn't really a right answer, even though there is a theoretically right answer, kind of like when you guys do the, I think you guys are doing thermodynamics right now. And so you learn about like standard enthalpy formation versus just the enthalpy formation, the actual chemical reaction that's happening versus how it would actually happen under normal conditions and perfect conditions. So under perfect conditions, there's like an answer that we're expecting, but there's going to be variation, and that's to be expected. And we want to see what you guys propose the relationship is based on your data. So that'll be exciting to see. Do you guys have any other questions on that? Because I want to be especially flexible with this, just to make sure you guys have everything that you need and that you feel comfortable submitting it. The theoretical answer is that they're directly proportional to one another. There's a 1-to-1 correlation, and the slope is whatever it is. I don't know what the actual values are, but theoretically, there should be a direct relationship between temperature and volume. So I would expect to see a linear curve with a pretty straight linear curve. Whether or not you will get that, I don't think, again, unless there's something really crazy wrong with the data. I think that so long as you're analyzing, so if you got data, for example, and it looked it looked like exponential. So you had, I don't know, you had your temperature 350 and you got a volume of 1. I think your temperature 375 and you got a volume of 5, and your temperature of 400 and you got a volume of 20. You know, if you're plotting something that's not even like it's not even an exponential curve, but if you got an exponential curve, then that's what you got, and that's okay. But that's theoretically what we should be expecting, is just a one-to-one. Basically, that the only thing that's changing here is temperature, and the only variation that temperature is producing in the only noticeable thing that we're observing is the volume change, and that should be a result of a dissociation of what is it? So the baking soda, so the dissociation of the sodium bicarbonate, the bicarbonate ions forming CO2 and rising as a gas, and that's a it's an endothermic reaction that releases, but also like it releases heat and energy, and that energy is a force that acts on the pattern.
I think my problem was, though, it was really hard to measure accurately to calculate the volume, because like I even included a picture in my lab report, and it's visible how the volume is way bigger and like the last trial than like the first trial, even though like you can see the volume is steadily getting bigger with each trial. But my data doesn't really reflect that, because the measurement was hard, because the cookies, they're not perfectly round.
Yeah.
And it's like also it was hard to measure like the height for the volume. Like I said, I had to remeasure it because the middle was like down, more like concave in. So I don't know.
Well, we'll look at it. Something else that I mean, it kind of seems moot, really, but it's not. It just is maybe currently. Whether I do it initially or whether I do it at the end, regardless, I'm going to normalize. I'm gonna curve the class. So really, let's say that if everyone does badly on it, which I'm not expecting at all, but let's say that everyone does badly on it, whoever does the best on it is going to get an A. And that's how I feel about the class in general. I guess I can talk a little bit about grades. So actually hate talking about grades, because I'm very upset with myself regarding the whole grade situation. But I really have no other option at this point. I was thinking of what kind of how to say, like what kind of leverage I can give you guys over me to like to damn well make sure that I give you guys something. But I kind of expect you guys to have pretty bad reviews on this, and that's fine. This is my mistake, my problem. But I'm thinking of something pretty bad, like something that I want to do, so that I definitively have to give you guys everything by this Friday, because it's way too late to give you something. So the only way I'm thinking about it now is I'm just more flexible with things. It actually can be slippery slope, so I don't want to get too flexible, because then the whole class will be, things can degenerate quickly. So the only thing I can do is get that to you. But I'm saying this in the context of long-term grades. So I don't ultimately give you guys your grades. I don't like the letter grade you get at the end of class is not something I will award you personally, but I will have a grade that I will suggest to Dr. Fuller, who will herself do some analysis on that and then determine the grades. But by the end of the course, what I expect to do, and this is what I usually do for all my labs, I'm just behind this semester. So in addition to like the review that we're expecting, and so by the way, we should have all the corrections. I mean, of course, you guys need to have your things first, but on your part, I don't really have a deadline for your corrections except till the last day of lab. There's probably a soft deadline, which is the week after the last day of lab. That's just pushing it a lot, because that week, the week after lab, is sometimes requested that we have the grade submitted already. So I would suggest submitting all your corrections by the last week. And they don't have to be complex. I can give you guys an example or something. So I mean, I'll send you an email with an example of what I'm expecting on that. But anyway, so on this note, I will make sure that by the end of the class, if you guys have anything that you want to talk about, anything with old assignments, with current assignments, if we want to go through revisions, that's great. And I will go through like with each one of you guys, I mean, via email. If you want to reach out to me in the Zoom chat, that's fine too. Just to make sure that you know where you're standing, that things have been as fair as possible so far, and that you're as happy as you can be with it. Like I want to make sure that this is ultimately a good experience. I don't want the pandemic and the pandemonium that it's ensued to ultimately, you know, be a stifling experience. I want this to be rewarding. So we'll work through that. I guess that was not a very concrete answer. I forgot what I was trying to propose, but basically I'll make sure that by the end of like probably the last 2 weeks that you guys will know where you're standing. And I mean, obviously I'm going to give you grades before that, but by the end of 2 weeks, we'll just have a lot of, I guess we'll have like a personal dialogue, and we'll make sure that we can get your grade up as high as possible if necessary. Anyway, so all right, let's see this question. If you do mention these things, it's only going to help you. So the more analysis you can do for this lab, for lab 5, the better, because there's not a fixed value that we're expecting, which is actually normally how it is for Gen Chem. This semester is weird because of the pandemic and because we're giving you guys data. Normally there is no like fixed answer, and really all I'm doing is grading you on normally everyone is graded on the technique and the methods that you're using. So as long as you are like basically, so the more analysis you can do and the more you can describe, okay, so this is what I propose, and maybe this fluctuation you can see here is due to this, and I'm talking about that in my conclusion because, you know, there's variation in the consistency, there's variation in the shape, so there's going to be some uncertainty there. The more you can do that, the better, because that's basically saying, yeah, like this is the best I could do with the data I had, and I did all the analysis that I could with the tools I've learned from this class, and this is the trend I propose. But note that there's this uncertainty associated with this data for this reason. And that's literally all you can do in science. You guys are limited by your tools. You guys are limited by the samples themselves. And this is an important lesson to learn in science, which is that it's not always about, you know, when you guys actually start to do this in real life, as if you're like getting involved in research, there isn't really there's not like a true value that you're expecting a lot of times. It's you're analyzing an unknown. So the only way you can be certain, or the only way you can express a certainty regarding the answer you propose, is by having confidence in your technique and by addressing any potential causes for uncertainty in the data. And if you do that, then basically the result you get can be considered like canon or literature value because your technique was right. So that's the most important skill. So yeah, how I'm based on that, the more analysis you can do, the better. It's not going to hurt you. It may not always help you, just including for all things out there. It usually does help you, but I mean, there's a chance you can do more analysis than you need, but it will never hurt you, and it will probably almost guaranteed help you. And no, for those of you who are asking, if you haven't gotten emails, it's not you specifically, it's me. I just have to get those to you. So that's on me. But I have very strong. I cannot, like, I'm really upset with the grades. I can't hold back any longer. So you guys will have to get this week. Like I mean, like, I can't give you guys any more time. It's really unfair to you. So that's that. Okay, so we haven't even talked about this week's lab. So sorry about that. But basically, all you need to know, the video is actually great. They did a really good job with the video. It's really clear. So really, I don't need to talk a whole lot because they even go over they even go to the pre-lab. They actually tell you explicitly what the objective is. They tell you the data you need to collect. So really, everything I'm talking about here is redundant. But basically, this is an observation lab. So instead of doing more qualitative analysis, you are making observations. So you can kind of see that in every section. I mean, there are 4 parts, but you can see the data that you're collecting starting on page 789. And really, you're recording 3 different states. You're recording if there is a color change, if there was no reaction at all. So there's nothing changed at all. If there's, so in the color change can be 2 things. It can be a change in the solution, or it could be a change in the solid, or it could be a change in both. And whether or not the metal is dissolving in the solution that or the solvent that you put into the well. Those are the 4 things. If there are extra observations you have, that's actually, that's wonderful. For example, if you observe bubbling, that might be something worth noting as well. That could indicate, speaking of redox, release of hydrogen gas, which in this case, if it was previously probably H0, or H positive, no electrons, it's probably going to act as an oxidizing agent, as an acid, and released as H2. Yeah, and I guess that's basically it. It's a kind of interesting lab. Apparently was a pretty fun lab to do. I did hear about this lab even before I even taught this for students, just because it's pretty. So hopefully it's still exciting and interesting just watching it in the video. The lab report format is the same as normal. You'll need to have the objective, the background, procedure, the data and results. So the data and results are more or less page 79 to page 81. So you can just include all that as that section. The post-lab calculations are kind of, in this case, more replaced by the post-lab questions. So everything from page 83 to 84 is what you should be answering for that section. And then the conclusion is just addressing the objective in the beginning. I can foresee this lab being pretty difficult though, because it's a pretty conceptual lab. It's not very quantitative, but it's very qualitative. So with that being said, I say if you guys have any questions beforehand, ask them. If you don't, then like normal, you guys are free to go. I have all your attendance. I have the participation so far. If you guys want to participate more, I can always modify that. That's fine. And on that note, I actually remember getting an email way early on about participation with emails. Likely, yes. At the very beginning of this semester, I was trying to be a little bit more strict. But as I've been kind of failing my duties with the grading, I feel like it's only fair to be softer on these things. So probably what I'll do is right now I'll just keep it as is, and then just gonna take the participation for this participating in Zoom, and you still have to come to these meetings. But for those who've been participating, like in Discord and email, I'll go back and I'll see the timestamps when I got these things, and I can modify the participation score. That's probably something I'm going to do at the end of the semester, though, like I was talking about before, where I'm going to have basically your grade, like the worst case scenario grade at the end of the semester, and then there's going to be modifications. Going to be modifications from your corrections, for any corrections with the homework, things that are still missed, for questions that you brought up with me, like for the grades, like you say, you look at this, like, well, I think I got this, but you didn't tell me I got this, then we can talk about that. And then also for things like participation, I can adjust that. So So bear that in mind. So it does certainly help you to just to participate in any way, and that includes email, talking in Zoom, or talking Discord. What else was I trying to say? Oh, so that's basically it. I would advise you guys, for those who are ready to go, just to start this next lab. Then you can go ahead and do that. I have attendance and everything. If students want to stay and we can analyze data specifically from like their data that they collected from lab 5, we can do that too. So I'll go over. I'll keep this Zoom meeting active, or whatever else you guys want to talk about. That's fine. If you don't, that's fine too. Whatever. If you have more questions, post them on Discord. If there's some discrepancy you're seeing in the homework, post on Discord, and I'll work on that. If no one's asking me a question, I'll just actually I'll work on the homework first and adjust the grading scheme for that. But yeah, that's everything.
Thanks, Dylan.
All right, well, see you guys for who wants to go.
Thank you, Dylan.
Thank you.
Hey, Dylan, I just have a quick question before I go, actually.
Yeah.
I just want to know, like, overall how I'm doing on my lab reports, because I'm not, because I don't have a feedback or whatever. Like, I don't know exactly if I'm going I'm not doing enough in certain things, or.
So, so I'm only being hesitant because, okay, so I guess it doesn't really matter because you're going to get your grades regardless.
Right.
Every semester there are few students who are usually very much on top of things and do well, and they are students that I use to kind of set the standard for the class. And you are one of those students. There's about 2, maybe 3 others that I also kind of have as like like in the same category, but basically I wouldn't worry. I don't really have something that's screaming to me right now. You know what I think I was gonna do, because this got super overwhelmed with everything. Like with you, I don't have the exact same real life problem, but I have other real life problems, and so I think what I'm gonna do is, instead of just going through every single, so far I've been going through individual like labs and one student at a time.
Right.
Which is fine. It's great. It's always what I've done. I think I might mix it up because I'm more behind than I'd like to be. And I might just start going one student at a time. Just have everything and then just set the standard and then just go kind of in progression. Like I was saying, starting with the better students that I know basically I can get through pretty quickly, because usually the good students are the ones who grade the fastest because I don't have to correct anything.
Right.
Or very much. And then I can go down. So I think I'm gonna do that today. So this is very candid, and the reason why I was being hesitant is because it's like, well, I don't suspect this to discourage you, but some students will become complacent with that kind of thing, but usually not. Actually, not the better students. So
no, I just wanted to I just wanted to know if there was anything that was like specific that stuck out to you that I'm not doing that I needed to get better on. I feel like from what you were saying, there's definitely some things that I could have probably corrected on some of my labs. But yeah, I don't know. That's why obviously just asked you, because if there was anything that really stuck out, then obviously you would know. So
I think what I'll do, so I guess I just kind of said this, but I think I'm going to do that. I think I'm going to just go one student at a time for now. it's less overwhelming for me, ironically, that way. And that way you can get some feedback regarding things that you can do better. I'll just, like I've said before, if I see recurring pattern, you have the option to correct it, and then you basically have until the end of the class to correct those, and you'll get the points back. Is like depending on your answer. So that's a huge boon to make up something. Because of my guilt associated with getting the grades back this late, I'm trying to think if there's something else I can do, but I want to look at the grades first once I get everything in, because if the thing is, if everyone, even though I want to be fair to everyone, like I want to be more lenient, being overly lenient actually dilutes the grades of the better students and inflates the whole class. And so I still want to have a spectrum.
Right.
So basically, yeah, I keep disappointing myself with my own deadlines because I keep failing them. So I'm not even going to give you a deadline besides this week.
It's no
but I'm going to work on it.
There's no pressure whatsoever on my side. I was just curious if there was something that's specific that's like sticking out that you had to say, Rowan, man, I know this one thing for sure that you need to work on. But it seems like there isn't. So that's really all I wanted to know. So
I'll let you know if I find something. I'll let you know.
Thank you.
And then you'll have the option to get it back. This is something that I'm happy about because it should give you the opportunity to correct that kind of thing. Like that shouldn't be something that should have been something that was corrected from the beginning. And it's basically it's not even like a real favor because you should have been doing this from the get-go. It's on me if that kind of thing is there. So I'll let you know. I'm gonna start with the homework right now unless someone asks questions in the Discord. So I'll get those corrected and then I'll just go back onto you. I'll probably start actually with the last stuff.
Okay.
So if you submitted 5, no, you haven't submitted 5. So I'll start with 4 and then move backwards. Actually, that'll be pretty quick. So yeah, I'll do that.
Okay.
Then
Sounds good.
I'll send you the feedback.
Thanks, Dylan.
Yep. See you, Ren.
Later.